Okay, so the first thing that this problem tells us to do is to find two cities, one in the northeast and one in the southwest. I chose Moscow for my northeast and Puerto Williams for my southwest. Moscow has a June solstice at 17 hours. That's the daylight hours. In December, the solstice is 7 hours, and the equinoxes in March are in September, and they're each 12 hours. In Puerto Williams, the solstice in June is 7 hours, and the December solstice is 17 hours, and the March equinox and September equinox are 12 hours apiece. So the main differences between the main things about these graphs. Okay. The problem tells us to create a sine function that models the hours of sun in each city, such as this or this. So the first thing we need to do is define the highest and the lowest hours to find the amplitude. So the amplitude is just basically from here to here, and we know that the amplitude is 5. So for Puerto Williams, since it dips first, goes down like this, and it's the opposite of this graph, we know that it's -5. So then we can determine that there's a vertical shift in the graph. It goes up 12. So this is because the starting point for the amount of hours at the March equinox, which is where we're starting the graph at the March equinox, is 12 hours. So for the period, we have to set the period for the whole year. This means between each max and min, 3 months pass. It wasn't modeled perfectly in these graphs, but that's the idea I'm trying to get across. We're going by months, so the period would have to be 12. Since 2 pi over b is the period, we'd have to set up 2 pi over b equal to 12. And then we would get b is equal to 6. So that when it was multiplied by t, we can get 2 pi. So when it was multiplied by t, we get 2 pi t over 6, which is basically just pi t. This would be over 12, and we just get pi t over 6. And that is what our period is in both graphs. And we have the vertical shift here, if I didn't say that already. Finally, we can start putting everything together. We have two sine graphs. So here we have the Moscow one, and here we have the Puerto Williams one. This is the exact opposite of these graphs are opposites, and this makes sense because they are on opposite sides of the world. So they would have the opposite daylight hours. The starting point of both of these graphs was the March equinox.